Okay, I'm going to go ahead and go over this activity from 1.1 about functions. It's the first part of the homework where they're just giving us relations, which is just pairings of ordered pairs, different kinds of pairings, whether it's numbers or names or a picture. And they're asking us questions about the domain and the range. And once we've done the domain and the range for all these different types of presentations, we'll go back and decide whether or not they fit the definition of a function. So this is part of section 1.1. I know there's a lot of information in it. If you would like to go over this activity with me, it is in Moodle. It's the one that says 1.1 domain and range. If you want to print it off, you can kind of go through this as I go. So if that's what you're interested in doing, hit pause and go print this off, and then you can come back and we can talk about it all together. Okay. So I'm going to assume you've either hit pause and you've come back with your print, or you're not going to do a print. So let's go ahead and move on. All right. So these pairings can be presented to us as literal ordered pairs, where they are just shown to us in the numeric form in parentheses and all that stuff. They can be shown to us also as ordered pairs instead of ordered pairs graphed as a point like this, rather than the actual XY values being attached to it. So this is a different collection of points than this picture is down here. Okay, and we'll continue to see others, but domain and range, the domain would be, in a situation like this, the set of all the first occurring, or what we typically use as X values. So for the domain, we're looking for the set of all the first values. So I see, I'm not even going to bother to reorder them. So here I have 3 that occurs first. And then the next one is -2. Next one is 13. And the fourth point also has 3. I already have 3 in my list right here, so I'm not going to write it again. It's just supposed to be the set of all numbers that occur first. And I already have 3 written down. Since it is a set, I'm also supposed to be putting the set notation brackets around it. This means the set of these elements separated by commas. So this actual presentation is also a set of ordered pairs. See, we have the curly bracket, the first point in a comma, and the second point in a comma. So that's a set of ordered pairs. The domain from that set is just the set of all X values. And then the range is going to be the same idea, set of all the values that occur second, or what we typically call Y values. So 4, 0, -22, and 10. Okay. So domain and range, if it's written as a list of ordered pairs like that, or if it's listed as a table, this is a similar presentation. I didn't put this on this sheet, but you see this in the homework as well, where they show the pairings. It's just 2 columns of numbers side by side. You can tell by 2 numbers that occur on the same line that they are supposed to be paired together. So if you see a table like this, or maybe it's presented horizontally, or you see the list of ordered pairs, domain is just a set of all the first occurring values, or the X values. Range is the second occurring, or Y values. Okay, same idea. If we're just given a picture of scatter plots, we just have to know how to read off the X and Y values for all these points. So again, the domain on this one, the X values, I'm just going to go from left to right. There's no particular order here. So I'll go -4. This one would be -2. I'm reading the X values here. If I'm going left to right, the next one's down here. That's got an X value of 0 because it's on the Y axis. The next one out is this one. It has a X value of 1, and the last one has an X value of 3. So those are all the points. There's 5 points, and they all had different X values. So there we go. The range, same thing. My bracket a little better. We have to read off the Y values. And again, it doesn't matter if you go from the bottom to the top or left to the right. So I'll go through the same order again. So this one has a Y value of -1 and so on. This one, because it's on the X axis, has a Y value of 0. This one has a Y value of -3. The next one has a Y value of +3. And the last one has a Y value of +1. So domain are the X values, range is the Y values. Okay, if it is not presented as clear pairings of numbers, which you can see them paired like this, or you can see by its position on the graph what the X and Y numbers should be, then we have to do something a little different. So sometimes it's presented as a graph. So you see this one, there's another one below it, where it's just a graph with a line or a curve. And we're still talking about the collection of all of the points that would be anywhere on this curve. And of course, there's infinitely many, so it's not going to be possible to just list them like we did up here, because no matter what points I decide to list, if I decided to just list all the points that are on whole numbered integer values like this, okay, there's all these points in between that you could never possibly list them all out. So instead, what we do is we talk about an interval of numbers. I say, well, the lowest x value that we see is this number, and then the highest x value we see is another number. And we say that the picture that I have drawn here, if x stays between this number and that number, we'll have all of the points on that little oval. Okay, so let's remember what x value means. It means everything that is related to this horizontal axis. So this thing doesn't cover everything. Unless we're right on the circle, there are no points out here on the x-axis that correspond to these x values. But when I get right here, the farthest left point right there has an x value of -1, or it appears to. And then this one over here is the farthest out to the right that x value goes. It has an x value of +3. So for this particular picture, all of the x values on all of these infinitely many points have to be an x value that is at least -1 and no more than +3. So I could pick any number between these two numbers. I could pick a number like 1.105, just making something up. So x equals 1.105 would be something in here, and it would be that point, and probably that one up there as well. Okay, so as long as I keep x values between -1 and +3, I'm on that picture somewhere. Okay, so my domain would be between, I'm just writing this in words because I'm going to show you a couple of ways we can write it more formally. Okay, so the range, same idea, in that most of the y-axis here, values, are not going to correspond to this graph unless you get right in this area here. If you're at +7, you're at the very top of the graph. So anything lower than +7 on the y-axis will correspond to something on this graph until I get down to the y value of, this is 0, 0. This would be a y value of 1 right here. So between the lower value, y value of 1 to the higher y value of 7, between 1 and 7, we're on the graph this way. Okay, so the range would be, the y values would be between, I'm always going to say the lower number first, 1 to 7, 1 up to 7. Okay, so this idea doesn't list out numbers, it just lists the edge of an interval of infinitely many values. So we can't use like a set notation and list them out. So there's a couple of ways that we do have to list it out. These two down here kind of describe exactly what I have written, but instead of words, it uses inequalities. So if I look at part G here, it says the set of, it's still a set, the set of all x values, the colon means such that the following statement is true. So such that x is between -1 and +3. The less than or equal means it can equal either one of these numbers on the edge. Okay, so this is using an inequality to describe the x values. Anything between -1 and +3. Okay, so that would be a domain value. Down here, same thing, it's describing y between 1 and 7. 1 is less than or equal to y, less than or equal to 7. That means y can be equal to 1 and 7 or anything in between. So that would be a way to write our range value. Okay, so if I'm going through all these multiple choice, for sure, G is one way to write how to represent the domain, and H is the way to represent the range. There's something else that's even shorter notation than this, is math people love shortcuts, and it's called interval notation, where we all are in the math world and we just agree that we're just going to say where it starts and when it stops. Okay, so if we're looking for all the numbers that are between -1 and 3, we're talking about the interval that starts at -1 and stops at +3. That's what this is right here. So sometimes we use interval notation when we just want to talk about a section of the number line between -1 and +3. The square brackets, because you notice sometimes there's parentheses as well. The square brackets means we are allowed to include those cutoff numbers as part of the set. If you compare answer C to answer E, this also means all the numbers between -1 and 3, but it doesn't include those edge values. But we're going to assume those points really do hit those values. So C is another way that we could represent all the x values between -1 and +3, including the endpoints. So similarly for h, if we were just looking at the picture and saying, well, y is between 1 and 7, here's a statement that says y is between 1 and 7, but this is also an interval that says all the numbers between 1 and 7, including the edges. So D is another way that we can use that. So this is called interval notation, and you will probably see this asked for in my math lab quite a bit, because it's the most efficient way. Math people want to come up with this writing as little as possible. So these are all interval notations right here. So these two are the domain and range if we think of it as intervals. This is how we would say it if we were using inequalities. But that's what you have to do when you have a constant, like a smooth line or curve. You can't just list off individual points like this. Like this is also x values between -1 and 3, but it's only the integers. It doesn't include all the decimals and fractions that fill in between the whole numbers. Okay, so if your relation is presented to you as a picture, we're talking about the domain being looking at from the left to the right. That would be your interval for x, and for the range, you would be looking from the bottom to the top. You always say the smaller of the two values first. Okay. Okay, sometimes we have pairings that aren't really about numbers at all. This was just something like, these are the names of some students, and this is the type of place they live in. Okay, so we can see, if we're going through here, Bill lives in an apartment, Hector lives in a dorm, Margot lives in a house. Anna's in an apartment, Larry's in an apartment, Harriet lives in a dorm also. All right, so if we're just talking about domain and range, this is sometimes called an arrow diagram or mapping diagram. This one's pretty easy because we always draw the domain on the left and the range on the right, and the arrow is used to show the pairings. So the domain would just be everything in that first circle. So Bill, Hector, and so on. Margot, Anna, Larry, Harriet. I'm going to be lazy and just use their initials. Okay, so the range would be all the different kinds of places they could live: house, apartment, dorm. Okay, so if you see an arrow diagram, that's a super easy one to identify domain and range because it's similar to your tables. You just, everything on this side is domain, everything over there is range. Same thing with the mapping diagram. Okay, one more thing here on the graphs types of things. Here's one that it has a definite starting point there. I don't know if you can see on the camera, but there's a definite point there where it starts, and there's nothing out here. It just starts there and it takes off to the right, goes up, higher, higher, and there's an arrow on the end that's supposed to indicate it just continues to go up and out forever and ever. Okay, so we're going to have to use intervals on this one again. The domain, just like we did on this one up here, the domain would be the furthest left point's x value. So that's the furthest to the left. And I guess it's hard to see, but this is my y-axis right here. This is x and y. So this is x, this is y. Didn't print off all that great, but that's my y-axis. So that's 0, 0 right down there. Okay, so the x value, if this is my y-axis, that's -1, this is -2. So the lowest x value we can have, the furthest to the left, is -2. And then it doesn't have a right limit. It just is unlimited. It goes on that way forever. So it goes out as far as I can imagine. I could go up high enough and hit the graph. So the domain starts at -2, and I'm just going to use a comma, kind of like we did up here. But if it's unlimited in a particular direction, we use an infinity symbol. So this means it starts at -2. There is no upper limit on these x values. It goes on to infinity. And no matter how far out I go this way, I could go up high enough and eventually land on this graph. So there will always be a point associated with it. Okay, so intervals require grouping symbols around them. So if the number is included, again, that's a square bracket. An infinity symbol will never have a square bracket because it's not really a number you can include. So if there's an infinity symbol, we'll always have a parenthesis around it. If something is unlimited on the left, like it was flipped around going this way, then there is no lowest x value. So we would write that this goes this way, and that would be like negative infinity. So if something goes off to the left forever, we start the left-hand side with negative infinity, and then we write down the number where it stops, assuming it stops somewhere. Okay, so we're going to do the same thing now with the range. just like it was up here, the range starts from the lowest y value. Well, the lowest point was also this one that was furthest to the left, but the lowest point corresponds to what its y value is. Okay, so if this is 0, 0, and this is 1 and 2 on the y-axis, the y value associated with this point is 0. So the lowest y value it has is 0. But in the same way we talked about it goes this way forever, it's angled up, so it goes up forever as well. So no matter how high up I went on the y-axis, if I went out here far enough, I would eventually run into this graph. So this graph has all the numbers associated with the positive y values. So it's unlimited as we go up. So again, we're going to use a infinity symbol to say the lowest y value is 0. It is included. The little circle was colored in, which means that is a point that's included. And infinity always has a parentheses around it. Okay. The only other domain and range things that you're going to see on the homework are the one other way that you can have a relation expressed to you other than pictures like this or a mapping diagram would be if it's written as an equation with x and y in it, and they're showing the relationship between x and y, that you could just make up all kinds of x values, compute a y value to go with it, and you could generate as many points as you want, and you can kind of connect the dots on some of those. So when it's something like this, where they don't give us a picture and they don't give us a list of points, but they give us an equation, most of the time, the stuff that we cover in our class, the domain is going to be everything, all the real numbers. But in this case, if it has a square root in it, this is one of those times when this particular expression, we have to be kind of careful about what x values we could choose, because you're not supposed to take the square root of a negative number if you're trying to create a graph. Some of you may remember square roots of negative numbers are imaginary. They make an I thing, and we don't really have a way to graph an I number on the regular coordinate system here. So all we know for sure is that this piece right here can't be negative. So you're not going to really be asked for probably domain and range of these unless we're looking at a graph. In fact, this right here is another type of a square root type of thing. But what you do, typically there's just the same thing you'll do every time. You take what we call the radicand, that piece that's under the square root, whatever it is, and you always write this. All we know about this is that this expression has to always compute so that it's not negative. So greater than or equal to 0 is another way of saying not negative. And then we're going to solve this for the x, because all the domain just means what x values could I choose that would produce an output that we could get a point for and all that. So we're just wanting to know about x, not this whole 10x minus 30. So we're going to solve this for x just like we solve anything. We want to know what x could be. So we're going to use it just like an equation. We'll add 30 to both sides. Equals 0 plus 30 is 30. Divide both sides by 10. So for 10x minus 30 to stay positive, I have to choose x values that are greater than or equal to 3. So 3 is the lowest x value I could choose, plug it into that expression and get something I could use to graph. So like if I put in 3, 10 times 3 is 30, minus 30 is 0. So when I put in 3 for x, the value that computes for y is 0. So 3, 0 would be a point that I could use there. So we can use, as long as it's 3 or bigger than 3, that could work for the domain. So when you're doing the domain for a square root function, this is what you do. You take whatever's under the square root, that's called the radicand, set it up to always say greater than or equal to 0, solve it for x, and then that's how you would say the domain in an inequality statement. If I needed to do it as an interval, we would say, well, the lowest value is 3, and it's unlimited as long as it's no lower than 3. So that's how you could do the interval for the domain of that. Okay, so on the square root functions and also on these fraction looking type functions, you'll just be asked about the domain. They're not really going to be so concerned with the range, but you could always graph it once we learn a little bit more about graphing, and maybe kind of do it like this. Okay, so one of the special kinds of equations that have a restricted domain, so you have to kind of do a little bit of algebra to figure out what values you can use, is the square root one. The other one where we have to be a little bit careful is when it looks like a fraction and we have a variable in the denominator right there of the fraction. If I have a variable in the denominator, That means it's possible that I could pick a value to calculate as the input and accidentally throw a number in that denominator that makes it compute to equal 0. And we're never supposed to divide by 0. We really don't have any translation for that. Your calculator says no when you try to divide by 0. So all I know for the fraction ones is whatever is in the denominator is not supposed to be 0. You can literally pick X to be anything else in the whole universe except, I think you could look at it and see in this case it's -4. But if it's something you can't just tell, you just do the same kind of idea that we had over here. Take what you know about it. Denominator cannot equal 0. And then you just solve it for X. If the denominator can't equal 0, -4 from both sides. That's the same thing as telling me X cannot equal -4. Don't care what's in the numerator. It's just about the denominator. Okay, so as long as X is not equal to -4, we're good. So the domain on this one, the easy way to say it is just like I have it written here with an inequality. It just says not equal to -4. If you do it in interval notation, it's kind of crazy because you have to build intervals for everything on both sides of -4. So like everything from -infinity up to -4. And then you do this little union symbol, everything from -4 all the way up to +infinity. And this is one of those times when you would actually put a parenthesis around the number because we're specifically ruling out the value of -4. So this is like a horrible, I believe they do ask for it maybe once in the homework. So if you see something like that, it might just be multiple choice, but just notice this is a way of writing everything on the number line except -4. It's much easier to say this, X not equal -4. But this is the formal way to do it with intervals. You'd have to build two separate intervals around -4, parentheses around the -4 to explain we're not allowed to use -4. And then the little u means the union of the elements on this side with the elements on that side. So this is like the horrible way of saying don't use -4. Okay, so that's the domain and range ideas when you're given all kinds of different ways that the function could be presented to you, or it may not be a function. The only one I really didn't put on here was verbal description. I could have maybe written this as a verbal description instead of a mapping diagram and just said we have a relationship between the person's name and the type of place they live in. And then you're going to have other questions that also give you presentations, but maybe instead of asking for domain and range, or maybe in addition to that, they're going to ask you, is this a function, yes or no? Okay, so I'm just going to talk that briefly through that. We have all kinds of different pairings, like this is a pairing that kind of makes a closed oval type of thing. But a function very specifically means if I choose an input value, a member of the domain, just at random, is there only one possible output that could go with it? That's what a function means. For any X value, there's only one possible Y value that could go with it. So if you see something like this, well, you can see it here and you can see it in the list. See how this number 3 for X value? If I said, hey, what's the number that's paired with the domain value of 3? There would be a question, right? You say, well, you're talking about the 4 or the 10. There's 2 points here that have the same X value. That means 3 is being paired with more than one output. So this is an idea that is not a function. So for it to be a function, that you cannot have X values being repeated with different Y values. Okay, so if we were going to go back through and just say function or not, because you'll see some questions that they show something to you and say, is this a function, yes or no? If you miss it, you don't get a chance to correct it. They make a new problem and make you think about it again. But on this one, this first one here, the function, it would not be a function. This first one. And that's because we have 3 is repeating. X equals 3 repeats. And it repeats with 2 different numbers. Once it's listed with 4 and it's listed with 10. To be a function, you have to know for sure what the output is when you pick an input. Okay, so if you have a picture like this, it's actually pretty easy on a picture once I kind of explain it to you. If you think about, here's a case where we know this is not a function based on the definition of a function being all the X values are different. if I have 3, 4, I go over 3 and up 4, and then I have 3, 10, so then I go over 3 and up 10, I'll have these 2 points that have the same X value. They just went up a different amount. So they're stacked up vertically right on top of each other. So if you see a graph where you have at least 2 points on the graph that are vertically aligned, that means they share the same X value, and then it would fail the definition of a function. It's actually called the vertical line test, if any of you remember doing that before. So if I was to take, I don't know, I used to call it like a pencil test when we would have classes to do this. But if you had something, you know, like my little Christmas pencil here, if you take a vertical line, think of it as a pencil, I don't care, pencil lead or something, and you just kind of roll it across or slide it across the graph. If at any point you're hitting 2 points at once with the same vertical line, that means you have 2 points that have the same X value and different Y values, and it violates the definition of a function. But as long as you only ever hit the graph with the vertical line 1 point at a time, which is what these red points are showing, they're all spread apart. There's none that are aligned vertically, then this does fit the definition of a function. That's the only point. That's the only point, and so on. So this one is a function because all the X values are different. Okay, but you can also think of it as it passes what we call that vertical line test. You can look in the homework, I'm sure, and it'll explain it in a little bit more detail, like when you go to the links to the textbook, but that's basically what it means. It passes the vertical line test. There is no place where it hits it 2 times with the same vertical line. As opposed to this guy, if you go through this one and you start trying to pass a vertical line over it, pretty much except for right at the very edge when you're hitting it right on that edge point, every vertical line is going to hit it on the top piece and the bottom piece, right? So if I pick, for example, where X is 0 right here, okay, there's a point and there's another point where they both have the next value of 0. If I picked the X value of 1, I've got these points. If I picked 1.5, it would be these points. If I picked X equals 2, there's 2 places. So this graph kind of doubles up on top of itself. So there are lots of places where you could put a vertical line and hit it at 2 places. So that is not going to fit the definition of a function. If I said, hey, what's the Y value when X is 1? We wouldn't know for sure because here's where X is 1 and there's this low point and there's this high point. So functions mean you can only ever have one possible Y value associated with every single X value in the domain. So this is going to be, it is not a function and it fails the vertical line test. Because fails vertical line test, I'm being like a math person and putting all kinds of shortcuts on here. But the vertical line test is what sometimes was called the pencil test. Yes, you hit this graph more than once with many vertical lines. Okay, well, the equivalent of it, if you have a mapping or a arrow diagram, you just look at how many arrows are coming out of each member of the domain. As long as you just have one arrow, every arrow represents a pairing. So as long as there's only one arrow coming out of each member of the domain, it is a function, because that is what we have here. There's nobody that's living in 2 places at once. So it is a function. Okay. Let's look at this one just for practice. This is another graph, but if I think about the vertical line, it doesn't double up on itself like this one does. So every time, most of the time you don't hit it, but once you get to -2, you hit it, but just 1 point at a time. It's only ever going to be this 1 point. It doesn't peel back around and get underneath itself. So this, by the virtue of the vertical line test, is a function. And if they gave you something like this, which was just the equations, we'll talk more about this hopefully on Wednesday. We'll talk about how to graph things, but it would probably just be easiest to graph it and then see if it fits this form. But I can tell you that the square root ones and the rational ones like fractions, they are functions. So that's just something to know. All right, so I know that took a while, but I just wanted to go through how do you tell if something's a function or not? How do you identify domain and range depending on how it's presented to you? And there's other videos from 1.1, but this one is just talking about domain and range and the definition of a function. So I hope that helps and helps you get through some of 1.1's homework.